Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So last the previous sessions we have discussing this engineering tribology subject. So in this subject, the main parameters are important terms are friction, wear, and lubrication. So we have discussed about friction, wear, and lubrication. So and then importance of lubrication and how to how to minimize the wear and how to improve the life of the component already we have studied. So in today we will discuss about another important thing. The phenomena is corrosion. So this corrosion, what is the importance of corrosion in engineering tribology? And then what is the main principle of this corrosion? And how many types of corrosions are there? What are the main factors affecting the corrosion? Uh, all these things will cover in this topic. So that's why along with friction, wear, lubrication, you must know about this corrosion phenomena. So first we will see introduction part of corrosion. What do you mean by corrosion? So any process of deterioration, that means destruction and consequent loss of solid metallic material through an unwanted chemical or electrochemical attack by its environment starting at its surface is called corrosion. So that is the definition of the corrosion. This thus the corrosion is a process reverse of extraction of metals. The extraction of metals, you are extracting some metals, but in this corrosion, some destruction, so deterioration is possible in this the process. So ultimately, what will happen? So the consequent loss of material is there. So this corrosion is not wanted, the unwanted thing, unwanted due to the environmental conditions. This corrosion will be possible on the materials components. So due to this corrosion phenomena, some material will loss from the component. That is, so some material due to this material loss, the component will fail. And also the life of the components also will decrease. To avoid this, so first you should know about this corrosion, and then so what is the importance of corrosion, and then how many types of corrosions are there, and what are the main factors influencing this corrosion, you must know. To avoid to applying some testing methods, or to applying some preventive methods, or applying some paintings to avoid this corrosion, you must know. So it leads to what will happen to protecting this corrosion. It leads to improve the life, and also the cost also will reduce. So example, the most common example is rusting of iron when exposed to the atmosphere conditions. Already you know. So whenever the iron metal component is exposed to the environmental conditions, atmosphere conditions, so what will happen? Some rust formation is possible on the surface of the component or metal. So during this layer of reddish scale and powder of oxide, that is ferrous oxide Fe3O4, is formed. then the iron becomes weak. Whenever this formation is there on the surface, so the material, the iron becomes weak. You can't use those type of materials, iron, for specific applications. So see, in this figure, you can observe some corrosion phenomena. See, this is the mechanical component, that is coupling, the flange coupling. Two pipes are joined with the help of this coupling. So the rusted part you can see. So this color also changed the surface color. So it means this undergone corrosion. See, this is before corrosion, after corrosion, before corrosion, after corrosion. So these are the examples for the corrosion phenomena. So what are the causes of corrosion? The metals exist in nature in the form of their minerals or ores in the stable combined forms as oxides, chlorides, silicates, carbonates, sulfides, etc. So already in previous slide, I told you whenever the metal, the iron or some other any material exposed to the atmospheric conditions, there is a formation of ferrous oxide. It leads to corrosion. The form of their minerals or ores like oxides, chlorides, silicates, carbonates, etc. exist in nature. The form of the form of for the formation of corrosion. The ore of metal is stable, pure metal unstable, corrosive product is stable. So next causes of corrosion continuation. So but man for this own purpose extracting the metal from these components. So for particular some purposes, so extracting the metal from these components, whatever you have seen in previous slides, silicate, carbonate, sulfides. So for particular objects, so we are extracting the metal. Therefore, the metal always looks forward or for favorable conditions to convert itself back to the compound which from it occurs in nature as its minerals. This natural tendency of a metal for conversion into its mineral component from is called corrosion. So the natural tendency of metal for conversion into its mineral compound from. But most of the cases, this occurs when the metal interacts with its environment conditions in the presence of polluted air, water, associated other materials also. So most cases, the metal interact with the environmental conditions. So those elements present in the atmospheric, those elements, those element attract or interact with this metal. So ultimately, the corrosion the formation is possible on the surface of the metal. So this is these are the causes of corrosion. The other cause, the natural tendency of conversion of metal into its compound from an interaction with the environment is known as corrosion. So already I told you. The corrosion of iron by conversion into an iron oxide is known as rusting. The corrosion of iron by conversion into iron oxide, Fe3, Fe2O3. The corrosion of silver by corrosion into its sulfate is known as transing. So these are the difference between this rusting and transing. So what are the effects of corrosion? The loss of useful properties of metal such as malleability, ductility and electrical conductivity, and there's loss of efficiency. So due to this corrosion, some mechanical properties or some chemical properties will be lost. So the mechanical properties already know ductility, strength and malleability. So similarly, the chemical properties, okay, the electrical properties, electrical conductivity, and finally the loss of efficiency also possible. So decrease in production rate because efficiency is less. Whenever the efficiency is a loss of efficiency is there, there must production rate also less. So the and replacement of corroded equipment is time consuming. So that to avoid this corrosion, increase in maintenance and production cost, and contamination of a product. These are all are related to this effect of corrosion. So what is the main principle of corrosion? So the principle of corrosion involves the deterioration of materials, usually metals, due to chemical or electrochemical reactions with their environment. The chemical reaction, chemical reaction means the corrosion typically involves a chemical reaction between the metal and substances in its surrounding environment. So whatever available in surrounding atmosphere in atmospheric conditions, those substance involves chemical reaction with the base metal, such as oxygen, water, acid. These are the substances. The base metal, suppose iron or salts, react involves react with base metal. This reaction leads to the formation of corrosion products like oxides, hydroxides, and sulfates, which weaken the material's structure. So whenever these formations are possible, so occurred, the metal, so automatically the metal, the base metal will be weakened. The structure also will be changed. The electrochemical process. So many types of corrosions are electrochemical in nature, involving the flow of electrons between different areas of metal surface. This type of process is also called as wet process. This flow of electrons occurs due to the variations in the local chemical environment, leading to the formation of anodes, where oxidation occurs, and cathodes, where reduction occurs on the metal surface. So always that cathodes, the reduction is possible; at anodes, oxidation is possible due to the variations in the local chemical environment. Factors affecting the corrosion. Several factors influence the rate and extent of corrosion, including environmental conditions such as humidity, temperature, and pH value. The presence of corrosive substances like acids or solids, the composition and structure of the metal, and mechanical factors such as stress or abrasion. So these are the main factors affecting the corrosion. So environmental conditions already you know, humidity and temperatures and some other substances like oxygen, nitrogen, other gases, and the acids, the corrosive substances like acids and salts, and the mechanical like stress, abrasion. These all are affecting the corrosion. The how to prevent and prevention and control. There is a strategies to prevent a control corrosion include the use of protective coatings like paints or plating, corrosion resistance alloys, cathodic protection methods such as sacrificial anodes or impressed current systems, proper design to minimize corrosion prone conditions, and regular maintenance and inspection to detect and address the corrosion early. So these are the prevention and control. So if you inspect the corrosion problem, so in early conditions, you can avoid, you can minimize somewhat loss, and the proper design also. By using proper design, you can control and you can prevent the corrosion. and you can use some special coatings. The use of protective coatings also leads to control the corrosion or prevent. You can prevent the corrosion. These are the strategies to prevent or control the corrosion. Next, some theories are there. Theories of corrosions. Two theories are there. One is direct chemical corrosion, dry corrosion, and electrochemical corrosion, wet corrosion. So already we have seen in previous slide the electrochemical corrosion, also called as wet corrosion. Direct chemical corrosion means dry corrosion. So dry corrosion or chemical corrosion, this type of corrosion occurs mainly through the direct chemical action of atmospheric gases like oxygen, halogens, H2S, SO2, N2. So these are the direct gases, atmospheric gases reaction with the metal. So, these type of corrosion is called as dry corrosion. Again, there are three types of chemical corrosions are there. One is oxidation corrosion, corrosion due to the other gases, and a liquid metal corrosion. So we will discuss about these three one by one. So what is this oxidation corrosion and the corrosion due to other gases, and then liquid metal corrosion? The first one is oxidation corrosion. This is carried out by the direct action of oxygen at low or high temperatures on metals in absence of moisture. So without moisture, the direct reaction with the action of oxygen at a low temperature or high temperature on the metals, some oxidation formation is there occurred. So alkali metals and alkaline earth metals are rapidly oxidized at low temperatures. So the chemical reaction you can see here, at high temperatures all metals are oxidized except Ag, Au and Pt. So the two here see you can oxidation equations are there. A reduction and then overall net reaction. So all metals oxidized like this. So mechanism of oxidation corrosion. Initially, the surface of metal undergoes oxidation and the resulting metal oxide scale forms a barrier which restricts further oxidation. The extent of corrosion depends on the nature of metal oxide. So nature of the metal oxide, if the metal oxide is stable, it behaves as a protective layer which prevents further corrosion. So if the metal oxide is not stable, so it not behaves as a protective layer. So in that case, you can't control, you can't prevent the corrosion. So example, the oxide films of AL as silica, SN, PB, Cu, chromium, etc. are stable and therefore further corrosion is prohibited. So these are the aluminum, tin, lead, copper, chromium, the metals. If the metal oxide is unstable, so already I told you, the oxide layer formed decomposes back into the metal and oxygen. The oxidation corrosion is not possible. Ag, Au and Pt do not undergo oxidation corrosion. So these are the examples for these metals. If the metal oxide layer is volatile, then the oxide layer volatilization after formation and leaves the underlying metal surface exposed for further attack. This causes continuous corrosion which is excessive. Example, molybdenum oxide comes under this metal oxide layer is volatile. So after formation of the leaves, the underlying metal surface exposed for further attack. In the case of metal oxide layer is volatile. Next one is if the metal oxide layer is porous. So the oxide layer formed as porous cracks. In this case, what will happen? The atmospheric oxygen penetrates through the pores or cracks and corrode the underlying metal surface. So what will happen under these small cracks or pores that defects, the holes, uh, leads to the underlying the corrosion formation on the metal surface. Corrode the underlying metal surface. This causes continuous corrosion till conversion of metal into its oxide is completed. Example alkali and alkali earth metals. So the oxide layer formed as pores or cracks comes under this metal oxide layer is porous. Next, filling bed worth rule. So what is this PV ratio? According to it, if the volume of the oxide is greater than the volume of metal, the oxide layer is protective or non-porous. So by using this ratio, you can you can say the oxide layer is protective or non-porous. If the oxide layer volume of the oxide layer is greater than the volume of metal, if the volume of the oxide is less than the volume of metal, the oxide layer is non-protective or porous. Alkali and alkaline earth metals non-protective and ALB oxide protective layer. So the PB ratio is volume of metal oxide upon volume of metal consumed. So how much volume of metal you are consumed and then how much volume of metal oxide. The PB ratio is slightly greater than 1, the metal oxide layer will be protective. So based on this value, you can say the oxide layer is protective or unprotective or is porous or non-porous by using this PB ratio. So this rule is called filling bed worth rule. The second type is corrosion due to other gases. This type of corrosion is due to the gases like SO2, CO2, Cl2, H2S, F2, etc. In this corrosion, the extent of corrosive effect depends mainly on the chemical affinity between the metals and the gas involved. The corrosion occurs between this metal, base metal, and the some other gases like SO2, CO2, H2S, and F2. The degree of attack depends on the formation of protective or non-protective films on the metal surface, which is explained on the basis of filling bed worth rule. In previous session already we have seen that the ratio. If the volume of the corrosion film formed is more than the underlying metal, it is strongly adherent. Non-porous does not allow the penetration of corrosive gases. So example Ag plus Cl2, 2AgCl, this is a protective film. If the volume of the corrosion film formed is less than the underlying metal, it forms pores or cracks and allow the penetration of corrosive gases leading to corrosion of the underlying metal. SnCl4, non-protective example. In third one is liquid metal corrosion. So in this type of corrosion, it is due to chemical action of flowing liquid metal at high temperatures on solid metal or alloy. So whenever the flowing of liquid metal with at high temperatures on the metal surface or alloy surface, such corrosion has been found to occur in devices used for nuclear reactors. And this corrosion involves either dissolution of solid metal by a flowing liquid metal or internal penetration of the liquid metal into the solid metal. Under these conditions, this liquid metal corrosion will be occurred. So both the modes of corrosion weaken the solid metal, just like in nuclear reactors. The example. So this type of corrosion is called liquid metal corrosion. These are the three types of corrosion. So these are the references I have taken. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.